My name is Louis Gentile. I'm the product specialist for the ACT. In this video, I'll introduce the ACT. We'll go through its operation. We'll go through the resulting data and the value it brings to your mill operations. The Absorption Characteristic Tester, or ACT, a sized or coated specimen is placed on a porous glass disc, 100 square centimeter, from which the specimen draws water, and the uptake of water is continuously monitored to produce a dynamic absorption curve automatically. We have two chambers. We have a chamber with an LVDT or sensor assembly, and the other chamber where the actual water is transmitted into the porous glass disc and then obviously into the paper specimen. The paper specimen is held by a rubber membrane. Manual Cobb, on the other hand, is a standard. That's what people are using, and that's what they've been using for 50 years. It's a test that everyone does that they would like to replace, mainly because it's less accurate, it's not as repeatable, and there's a lot more variability in the test result because of operator to operator dependency. There are three main reasons why the ACT brings value to your mill operations. Number one is the possibility of lowering your sizing costs by adjusting the sizing amounts. The second reason is time savings. Once you place the sample, the specimen, in the ACT, you leave it. After the 2 minutes, it's recorded, it's in history, and you can break back the history whenever you want. The third reason, the ACT is fully automated, which results in an accurate, more repeatable, and much less variability in the final result. In addition to what we're looking at here as we did in the 30-minute Cobb, if you look at the peak absorption, they're pretty similar. There's only one that's basically off, and that's this one here, which is the one noted on the screen. And something that we can also do is in your fixed tags, we can tag different times as the mill would like. And we can change these. We can add, say we want to add 30 seconds. What happens at 30 seconds? So we'll just add one to 30 seconds. This is very easy. And as I said earlier, the more important portion of this curve is in the area where it first water enters the paper. The initial absorption of water into your paper. That's what we're trying to achieve here. We do want to see the Cobb value, but we also want to see, more importantly, how the chemicals react to the paper. In other words, this one here is absorbing a lot less than this one, as an example. So we're looking at this initially, and then we're looking at the curves, difference in curves, which is difference in chemical addition. This is an example of a 30-minute Cobb done on a liner, top and bottom, where this absorption rate over time is the bottom, and this one here is the top. So as you can see, there's sizing differences in, from the top and the bottom. More importantly is what's going on here initially, which is the peak. And the peak value or the peak number is the initial uptake of water when the water first enters the sheet. The higher the number, the quicker rate of absorption. Most mills that I've discussed the ACT with, they would like more. Why? Because they're tired of doing manual Cobbs. And even if they do manual Cobbs, they don't complete manual Cobbs, no matter whether it's 2 minutes, 10 minutes, 30 minutes. So if you're interested, which you probably are, what we recommend is for you to send us some samples. We will run them, collect the data, review the data with you, and then go forward from there.